Hello everyone and welcome. A while back, I was teaching physics and math at a college, and whenever I showed students some of these mental math shortcuts, they were amazed. So I thought, why not make a video about a few of the tricks I used, and that many people still use. By the end of this video, you'll be able to do some of these scary-looking multiplications all on your own. I'm going to walk you through 5 powerful tips that can make multiplication surprisingly easy. I recommend sticking with me until the end, because tip number 5 is my personal favorite. And once you see it, you'll know why. Let's jump into the first tip. Tip number 1, when the right digits add up to 10 and the rest of the number is the same. For example, let's take 83 times 87. The right digits, 3 and 7, make 10, and the left digits, 8 and 8, are the same. So here's the trick. Multiply 8 by the next number, which is 9. That gives 72. Then multiply the right digits, 3 times 7, that's 21. Now just put them together. 72 and 21, that gives 7,221. Let's see another one. 81 times 89. 1 plus 9 makes 10. 8s are the same. Multiply 8 by the next number, which is 9. That's 72. And 1 times 9 is 9, but we always fill 2 digits, so that's 09. Put them together, 7209, or 7,209. Next example. 42 times 48. 2 and 8 make 10. Multiply 4 by the next number, 5. That's 20. And then 2 times 8 equals 16. Put them together, 2016. Another one, 93 times 97. 3 and 7 make 10, so we multiply 9 by 10, that's 90. And then 3 times 7 is 21. Put them together, 9021, or 9021. Try 26 times 24. 6 and 4 make 10. Multiply 2 by 3, that's 6, and 6 times 4 is 24, so it becomes 624. Here's another, 75 times 75. 5 times 5 is 25, and 7 times the next number, which is 8, gives 56. Combine them, 5,625. Finally, a bigger one, 752 times 758. The right digits, 2 and 8, add up to 10, and the rest, 75, stays the same. Multiply 2 by 8, that's 16, and for the left side, multiply 75 by 76, because we always multiply by the next number. Now, 75 times 75 is 5,625, and when we add 75 more, we get 5,700. Put that together with the 16 on the right, 57,016. So here's the rule. Multiply the left number by its next integer. Then multiply the right digits together, and just stick them side by side. Tip number 2, multiplying any number by 11. The rule is simple. Add adjacent digits from right to left. Let's start with our first example. 1234 times 11. Begin at the far right. The last digit 4 just comes down, so we start with 4. Now add the next pair. 3 plus 4 equals 7. Write that in front. So far we have 7, 4. Next, 2 plus 3 equals 5. That gives us 5, 7, 4. Then 1 plus 2 equals 3. So now we have 3, 5, 7, 4. Finally, bring down the first digit, 1, to the front. That gives the full result, 13,574. And that's how fast you can multiply by 11. Let's try another one, this time with a carry. 5,678 times 11. Again, start from the right. The last digit, 8, stays the same. Now add the next pair. 7 plus 8 equals 15. Write down the 5 and remember the carry 1. Next, 6 plus 7 equals 13 and add the carried 1 to make 14. So we write the 4 and carry 1 again. Then 5 plus 6 equals 11. Add the carried 1, that's 12. Write 2 and carry 1 more time. Finally, add the carry to the first digit. 5 plus 1 equals 6. Put it all together. 6, 2, 4, 5, 8. Or in full, 62,458. Tip number 3. Break or split numbers to make multiplication easier. The idea is simple. If a number is close to something round, like 100 or 1,000, you can rewrite it to make the math cleaner. Let's start with the first example, 989 times 9. 989 is just a little less than 1,000, so let's rewrite it as 1,000 minus 11. Now multiply. 1,000 times 9 equals 9,000, and 11 times 9 equals 99. Since it's 1,000 minus 11, We subtract that 99 from 9,000. 9,000 minus 99 gives 8,901. You can even see it as 9,000 minus 100 plus 1. Same thing. So 989 times 9 equals 8,901. Now for the second example, 307 times 13. Let's split 307 into 300 plus 7. Then multiply each part by 13. 300 times 13 equals 3,900, and 7 times 13 equals 91. Add them together, 3,900 plus 91 equals 3,991. So 307 times 13 equals 3,991.
Tip number 4, the difference of squares trick. This one is perfect when your two numbers are equally spaced around a middle point. The formula is simple. Instead of multiplying two numbers directly, you can square the midpoint and subtract the square of the difference. Let's start with the first example. 113 times 127. These two numbers are centered around 120. One is 7 less. The other is 7 more. Using the difference of squares formula, that becomes 120 squared minus 7 squared. 120 squared is 14,400, and 7 squared is 49. Subtract them, 14,400 minus 49 equals 14,351. Let's try another one, this time with bigger numbers. 989 times 1,011. Notice they're equally spaced around 1,000. One is 11 less, and the other is 11 more. That equals 1,000 squared minus 11 squared. 1,000 squared is 1 million, and 11 squared is 121. Subtract 1 million minus 121 equals 999,879.
Tip number 5, using a nearby base for multiplication. This trick works best when both numbers are close to some round reference point, like 100, 200, or 1,000. Let's start with the first example. 312 times 305. Both numbers are close to 300, so that'll be our base. We can write them as 300 plus 12 and 300 plus 5. Now, here's the pattern. Multiply the base by the sum of the offsets, then add the product of the offsets. So we take 300 times 312 plus 5, and then add 12 times 5. That's 300 times 317, which gives 95,100, and 12 times 5 equals 60. Add them up, equals 95,160. Now, let's look at a trickier one. 98.5 times 412. These numbers aren't close at first glance, but we can adjust them so they are. Let's double 98.5 to make it 197, and divide 412 by 2 to make it 206. Now we're multiplying 197 times 206, and those are both close to 200. That becomes our new base. Write it as 200 minus 3 and 200 plus 6. Using the same base idea, we multiply the base by the sum of the adjustments and then subtract the product of the differences. So 200 times 200 plus 3 minus 6 times 3. 200 times 203 equals 40,600, and 6 times 3 is 18. Subtract 40,600 minus 18 equals 40,582.
Since this is my favorite method, let's briefly see why it works. Take a base number, call it x. The two numbers we're multiplying are x plus d1 and x plus d2. Expanding gives x squared plus x times d1 plus d2 plus d1 d2. Factoring x from the first two terms, we get x times x plus d1 plus d2 plus d1 d2. That's the hidden form behind the shortcut. Visually, imagine a rectangle. A big square x squared, two rectangles xd1 and xd2, and a small corner piece d1 d2. Add them together and you get the same expression, the base times the adjusted sum plus a small correction. That's why the base method works. I hope you found the methods clear, logical, and maybe even a bit inspiring. If you'd like to see more math, consider subscribing. It really helps the channel grow and lets me keep creating more lessons like these. Thank you for watching, and I'll see you in the next one.